Okay, good morning, everyone. As you guys should know by now, okay, I have to mute everything. Right. As you guys know that I sent you an email, and the email has the review for the final, and it has as well the answer key, and it also it has a formula sheet for all the formula that you're responsible for. So kind of a summary for every possible formula you have. Everything is on the content area under the review. So please make sure you do the review. I mean, that's really crucial. Okay, any questions from your part before we start? All right. Okay, so before I start, a few minutes ago, I start looking at your quiz. I will grade it today. I'll give you the result. And there is obviously a lot of you are not being able to complete the square completely. So we're going to complete the square, and then I will cover ellipse, finish ellipse, and then we move on. So I didn't grade everybody, but I have an idea of what's going on. So let us see the rule for completing the square. The rule is that, suppose I have something like that, x squared plus bx, something like this. Okay, to complete the square, you add, so this is the algorithm, what x is multiplied by, which is b over 2 squared. That's really what you add, okay? And by doing this expression, when you add this, it will become x plus b over 2 squared. And it will be a plus if you have a plus in front of x, and a minus if you have a minus. So I will do the problem that I gave you on the quiz that as I said, I wrote it somewhere. Okay. All right. And I would like you to help me out. So I will not do it. I want you guys to help me to do it. So I gave you the following problem. And I told you this is a circle, and find the center of and the radius. And be careful that if you don't show me the work, I take a lot of points off. So I want everything with the work. All right, so all of you, I want to take this piece right there. To complete the square, what should I add? I should add. Okay, back to you. What should I add following the algorithm verbatim? Please get going. What's playing the role of B here? What's x multiplied by? What is x multiplied by? X is multiplied by 6. So what we take is, no, it's not 12. It's not 12. What's x multiplied by? 6. It's 6 over 2, which is 3. 3 squared. What you add is the 9. That's what you add. Okay, it's 6 divided by 2. The b is 6. 6 divided by 2, that's a 3 squared. That's exactly what you add. And as I said last time, when you add this from one side, you have to add it to the other, or you'll change what you're doing. All right, now for the second piece. Plus y squared minus 12y. Again, I'm going to ask you what should add. And please, all of you, because if you're not going to show me the work, I'm going to take points off. All right, 36. Do you agree with your classmate? Where is the 36 coming from? What is y multiplied by? By minus 12. It's the 12 you divided by 2. That's going to give me a 6, and then you square it. And this would give me the 36. 36 here. I add 36 from the other side. Okay, that's how we complete the square. Okay, a lot of you are messing it up, which is fine. That's why I quiz you, so I see what your mistakes are. Now, when we do this, this piece here will be x plus 3, the whole thing squared. What do I mean? Will be that. Means if you take this expression, I mean, that's really what it means. It means if I take x, and that's how you can check yourself. X plus 3 squared, if I take that, means if I multiply x plus 3 times x plus 3, I should get that. I mean, let us multiply them. X times x, x squared, plus 3x, plus 3x, plus 9. It means x squared plus 6x plus 9. So this expression and this are exactly the same. So we're not changing, we're just like rewriting. Now plus. This is going to become the y. Because I have the minus, it's the minus. Now what we add here is 12 divided by 2. That will become the 6. So in the picture here, it's what the b is divided by 2. So squared. Again, take y minus 6, square it. You get exactly this term. Now here we add those. Give me the 49. All right, so a lot of you are messing up with this. So now the center is minus 3, 6. And the radius is the square root of 49, which is equal to 7. End of the problem. Okay? Please ask questions as I move on. Good. So now we're going to do the, last time we did a lot with ellipse. I checked you all, but now what I did last time is completing square with the ellipse. And that's what I'm going to finalize today. So ellipse, we remember the equation is equal to 1. This is when the center is as the 0. And if you want the center to be at HK, it's the same thing, but instead of X, I put that. And this will make the center at HK. All right. So I'm going to do the problem that I've assigned for you. I will, which is the one that it's on bright space. You're going to do it together, and then I move on. So I will do C, which is not completing the square, which is actually the center, and so X minus 2 squared over 25 equal to 1. Okay, so the question is the center, what's A, what's B, and length of major axis. Okay, quickly, I want answers. Every one of you. What is the center? So that's an ellipse. It has the form of an ellipse. So what is the center of this ellipse? Let me start asking you because I want to hear your voice. That's my last week. I can do that. Okay. Rebecca, are you? Can you read the problem? I'm trying to follow, but it's blurry. Okay. Is this blurry? Kishan, speak up. Okay. Is this blurry? X minus 2 squared over 25 plus the quantity y minus 5 squared over 4 equal to 1. That's the equation. And I want the center, I want A, I want B, and I want the length of the major axis. And so I'm going to see if I can focus it a little bit more. Okay. And then we're going to graph. Kishan, can you follow me? Yes or no?
Yeah, thank you.
Okay. Rebecca, what's the center? Okay. Rebecca? Yes, I am here. So what's the center of the ellipse? Idea? Okay, the center is 2, 5. That's the H and that's the K. What's the A? So be very careful. What's playing the role of A? This is A square. This is B square. So what's the A, Rebecca? Equal 5, absolutely correct. What's the B? The B is 2. What's the length of the major axis? So it means that when we draw this ellipse, we have a longer axis. What's the length of the major axis? And we're gonna graph it. It's 10. And the smallest axis is 4. Very good. So now let's see how we graph it exactly. The center is 2, 5. That's it, 2, and that's my 5. That's the center of the ellipse. Now, A is 5. It means if we go from the center, we go 5 units this way, that's the A, and 5 units this way. And then the B is 2. Means I go 2 units up and 2 units down. This is the B in the picture. And finally, this is my ellipse. Okay. This is the B, which is a 2, and this is the A, which is the 5. So that's really my ellipse. So that's A, this is 5, and this is my B, which is equal to 2. Okay, that's really my ellipse. And that's the center, which is 2, 5. Okay, so that's the basic form of the ellipse. Now I'm going to do ellipse in disguise, and we're going to find the center and the radius. Okay. So I will do D. So this is from your note, this is from your homework, and I will write it bigger. So now this is x squared plus 121 y squared. So the number looks very big, but definitely we're going to make them look nicer. And plus 968 equal to 0. And basically we're going to graph all the points that satisfy this equation. I don't know why it's more blurry than usual. Sorry, I'm trying to see if this is better. All right, so let's do that. We have to complete the square, and let us remember how we did it last time. This is x squared stand by itself, it's completed. Plus, what shall I do here? What shall I do here? All the constant term, we move them to one side so we don't have to worry about them. And here I keep everything in terms of y. Right? So this will give me. Now, what shall I do after that? Anybody remember? Please pitch in. Remember how we finished this problem when we have a coefficient under y squared. I don't have y squared, I have 121 times y squared. Do you guys remember what we did?
But we factor out.
We factor it out. So we're going to factor out 121. All right, very good. What are we left with? If I factor out 121, tell me what shall I write here? Please, all of you. Or I will start.
Y minus 6.
What?
Would it be y squared?
That's y squared.
Y.
And this one, what should be this one? Anybody would know? What? Okay, I'm going to take 729, sorry, and basically divide it by 121. Sorry, 726, my apology. It's 7 to 6. So the problem usually are down, which is going to give me a 6. It means this term here is basically 6 multiplied by 121. So when I factor 129, I will left with minus 6y. And the problem is done, so you guys can handle it. All right, now we have to complete the square, and we have to be very careful, as I told you last time. So this is minus 68. I have to complete the square of this piece. So it's y squared minus 6y. And now what should I add quickly? You should not have problems, I hope, by now. What should I add quickly? What's y multiplied by 6 over 2? 9. Very good. If I add, what shall I add from this side? Remember what we said last time. What shall I add from this side? 1089. Yeah, Kathleen, where is this number coming from? I believe you, but I want to tell me where is this number coming from? It's 129 multiplied by 9. So it's 129 because that's what I added. I did not add 9. I added this times 9. Okay. And now let us see what we get so far. So this is really, so finally I'll end up and things will work well. I mean, things, no. This piece here, this is the one I was after. 1 minus 3 squared. Because this is the b here, the b over 2. As I said, we add the b over 2, which is the 3, equal. Now, I don't know how much did you get to the right. So it's 121 times 9 minus 968. So I'm getting 121. Anybody got anything like I did? Anybody? Yep. Anybody else? I mean, I just did the math here. Now, finally, it's starting to look like an ellipse. How can I let it look like an ellipse, exactly an ellipse? So it's look like it. Now, how can I make this into an ellipse? What shall I do? Remember, the equation of the ellipse, the standard form is x minus h squared over a squared plus that equal to 1. That's the standard form. So I have to divide by 121. And now I will be done. Over 121 plus over 1, because I divided by 21, this will give me equal to 1. So finally, so this is an ellipse. The center is 0, 3. That's the center. My a, that's the a square. So my a is going to be the square root of 121, which is going to be 11. And my b will be the square root of 1, which is a 1. So because this is equal to 1. Now a is larger than b, means the major axis, the length of it, sorry. It's going to be twice that much. It's going to be 22. And this is an ellipse centered at 0, 3. B is 1, means we go up by 1. A is 11, so it's really, it's a very, very stretched horizontally, a little bit too much. So I'm going to go from here 11 units. And I go here 11 units. We're going to have an ellipse which is very stretched horizontally. Very, very much stretched. Like you take it and you stretch it a lot. And that will be my ellipse. Okay. All right. So we do the last one and then we finalize. So the last one is the following. Plus y squared equal to minus 9. All right. So I'm going to give you all like 2 minutes to finalize this one. And if you guys get it, it means you are fine with that. So please, all of you, and I will ask one of you to see what you guys came up with while I do it myself. Okay. So I'm doing it at the same time you guys do it to have a feeling how long it's taking with you. Who's ready? Anybody ready? All right, anybody like to lead it then? Anybody likes to lead? I think I am Kishan. You give you the stage. Get going. Kishan?
Oh, sorry.
Okay. What should you do first?
I figured out the n for the x squared, the 9x squared.
Yeah. So what did you do first?
I did 9 parentheses x squared minus 2x plus y squared minus 6y.
What do you want me to do right now? Close parenthesis?
Yeah.
Okay, step number 1 is correct. Step number 2. How shall I complete the square here? What should I add?
Plus 4.
What should I add to complete the square of this expression?
Would it be plus 4?
I can't hear you at all.
Would it be plus 4?
No. What is x multiplied by? 2.
Negative 2.
You divide by 2, you get what? That's the b here. The b is negative 2. You divide it by 2, you get negative 1. You square it, you get 1. What you add is 1 to this expression. Now,
Okay.
immediately, when I added the 1, I have to compensate right here. But when you add the 1, you're actually adding 9 because you factored out the 9. Plus, what about this piece? What shall I add to it?
I added plus 9.
Plus 9. It's the same thing. I mean, that's the coefficient here is minus 6 divided by 2 minus 3. You square it, the minus is gone. It will be left with 9, and that's you add the 9 from here. So this 9 is coming from that 9. Okay, now the rest is just, okay, when I do this, the goal is to make this expression, this will become the x minus 1 squared. What you put here is the b over 2. That will become that. This would become y minus 3 squared, and this will become a 9. So now this complicated expression that we have no idea what it is become a very simple expression. Now divide by 9 across the board, because I want to make this a 1, will give me this. Over 9 equal to 1. And this will become over 1, because when I divide by 9, this will become a 1. This will become a 9, and this will become 2. So now that's an ellipse. That's the equation of an ellipse. The center is going to be 1, 3. My a here, my a square is the 1. That's the a square. It means my a is 1. My b square is the 9. It means my b equal to 3. Now b is bigger than a. It means the major axis has length twice 2 times 3, which is the 6. Okay, so I will graph it and then explain one more time the major axis. Graph it. The center is 1, 3. 1, 3. That's the center. Okay, that's a 3. Now, b is 3. Means if I go down, that's the b, which is 3, I go up 3. That's the b. The a is 1. 1 from here and 1 from here. That's the a. So my graph will be this one. That's what this will represent. And the major axis is the longer axis connecting the vertices. That's what we mean by the major axis. So this is the major axis, the longer axis connecting the vertical. That's what we call it. So it's the longer axis connecting this vertex with this vertex, which is equal to 6.
I have a question.
Yes, please.
So, why is this ellipse in only one quadrant?
Because of the dimensions. You know, the center, if we draw it one more time, it's really the dimension. I mean, I cannot, so the center is 1, 3, okay? So if I'm gonna graph it, I'll graph it again, and then you will understand why. It's 1 and 3, 1, 2, 3. That's the center of it, all right? And this is a 3. Are you with me?
Yes.
Okay, the b is equal to 3. It means from the center to the vertex, we have 3 units. It means that's the b, 3, 3 going up. Because it happens, the center happened to be 1, 3. If the center was 1, 2, then I will have to go down by 3 units. That's the b. The a is equal to 1. It means I go 1 unit this way and 1 unit that way. But this happened to be 1. It's just really pure coincidence in this case. This is the 1. And from here to here, it's 1 because the center is at 1. So they are the same thing. And that's why it's going to be like that. So the only reason is in the first quadrant is because the dimension, because what A is and what B is and what the center is. That's the only reason. Does this answer your question?
Yeah, thank you.
Okay. Okay, so I decided that I will drop hyperbola for this semester. So for those who will need hyperbola, you guys will learn it again. For those who don't, I will save you the hyperbola. And I think the best thing I can help you at this stage is start reviewing with you. So my plan is fairly simple. I'm going to start reviewing with you today, and I will review with you next time. And on Wednesday, we are going to have a short quiz. You will have a quiz. I know it's not on the syllabus, but this is my deal. If you guys take the quiz next week, I will drop the lowest 2. Instead of dropping the lowest quiz, I will drop the lowest 2. But then I will give you a short quiz next time that really emphasize, make sure that you guys know the ellipse very well, the circle, and how to complete the square. All right. Okay, so how are we going to do the review? My idea is actually going through exam 1, exam 2 by emphasizing, the main things we did in this course. All right. So the first thing is that we study trigonometric function. Okay. Trigonometric function is, first we have trigonometric function in a right triangle. and then trigonometric function in the unit circle. In the right triangle is what you've seen all the time in high school. So this is in a right triangle. Only what I'm saying here is in the right triangle. Okay, so in the right triangle, the definition of the trigonometric function is the sine is hypotenuse, opposite over hypotenuse. The cosine is adjacent over hypotenuse. That's in the right triangle. So the tangent is either sine over cosine or opposite over adjacent or sine over cosine. And then the cotangent is the adjacent over the opposite, which is the other way around, or cosine over sine, or 1 over the tangent. And then we have the secant, which is 1 over cosine, and the cosecant, which is 1 over the sine. So that's the picture in the right triangle that we have. So based on this, I'm going to do a small problem just to make sure you guys know everything in the right triangle, because it's crucial to know everything. All right. So we're going to do this problem, which is actually from, it's on your review, but I want to make sure all of you can do it. Okay. Can you see what I have here? This is a 4. I'd write it big. And this is x. Okay. And I want all of you to pitch in. My question number 1 is, what is the sine? I'm trying to focus, see if I can get a better picture. Okay. What's the sine of theta? Each one of you has to figure it out, and then we proceed. So what's the sine of theta? So I am working here with right triangle definition. It's the right, it's what's happening in the right triangle. Okay, so everybody is telling me, or what I'm having is opposite over hypotenuse. Opposite over hypotenuse. And my question is to give your answer in terms of x. All right, cosine theta, please, all of you, not only 1 or 2 students. What's the cosine of theta in terms of x? Okay, in terms of x, remember the cosine is the adjacent. So I'm working in a right triangle. Okay, equal to what? Okay. Any student who likes to talk, just, just speak up. You don't have to wait for me till I call you. What's the cosine?
Wouldn't it be the square root of x minus 4 over x?
Not exactly. You're on the right track, but not exactly. What is it you need? We need the adjacent, right?
Right.
How can we figure out the adjacent? Let me call this, let me give it a name. Let me call this a B. How can we find the adjacent? If I use Pythagorean, very carefully, what does Pythagorean theorem tells me?
It's a squared plus b squared equals c
Right.
squared.
Give me what you said in terms of the picture.
Oh, x squared minus 4 squared should give you b squared.
Okay, or this one. That's Pythagorean, right?
Right.
Okay, very good. So what's b squared? It's x squared minus 4 squared. Okay, so what's the b?
B is the square root of x squared minus 4 squared.
Which is?
16.
16. So did you know what your mistake was?
Yeah.
Okay, so that's the square root of x squared minus 16. Now you are on the right track. All right, so even though I did not give you one side, but we don't have to give you all the side. If we give you 2 sides in a right triangle, we can figure out the 3rd side very easily. So now the cosine is the square root of x squared minus 16 divided by x. Okay. All right. Now, what's the tangent? So I'm working in a right triangle. What's the tangent quickly? Please, any of you speak up. Don't make me call on you. I don't like that, but you're forcing me. What is the tangent?
Wouldn't it be 4 over the square root of x squared minus 16
Right. What's the tangent? It's the opposite
over the adjacent?
adjacent. That's in the right triangle. Everything is clear. So the opposite is the 4 adjacent minus 16. Okay. Very good. Now, what's the secant? So the goal here is to remember all your trick in a right triangle. What is the secant? So what's the definition of a secant? The secant is 1 over the cosine. Secant is 1 over the cosine. So now, what's the cosine? No. Okay, what is the secant? What's the cosine? You're flipping the cosine. So if the cosine is adjacent over hypotenuse, the secant is you're flipping the cosine. So the secant will become, oops, sorry about that. Sorry about that. Okay, so it is the hypotenuse over the adjacent. Okay, so the secant is 1 over the cosine. Means basically you take the cosine and you flip them. So this is going to be equal to hypotenuse is x, adjacent over that. Okay, what's the cotangent? What's the cotangent? So you have several, what?
Would it be a radical x squared minus 16 over x?
So let me say what you said, because somehow your voice is not very clear. Did you say that?
Yeah.
Over
x.
Over x. All right, so let us see the cotangent. The cotangent is the reverse of tangent. So the cotangent is the adjacent over the opposite. Okay, so you're not right. It's the adjacent over the opposite. The adjacent is the square root. The opposite is 4. So that's going to be divided by 4. Okay, it's basically you take the tangent and you flip it. It's the tangent, you flip it. It's the square root of x squared minus 16 over the 4. You flip the tangent. So go over the definitions very, very carefully. They are on the formula sheet I gave you, so you guys remember. Now, what's the cosecant? The cosecant is 1 over the sine. So whatever it is, so 1 over the sine. It means you flip the sign. If sine is 4 over x, the cosecant is 1 over it. So the cosecant is basically 1 over the sine. Now the sine is 4 over x. So it's 1 over 4 over x. You flip it. It means 1 times x over 4, which gives me x over 4. Okay, so that's a quick review for the trigonometric function in a right triangle. Absolutely, each one of them has to be memorized. Now, unfortunately, you guys are doing it online, and I cannot make sure you're memorizing them. But for your own benefit, you have to memorize those. You have no way out if you want to move forward. Okay? Questions about that? So that's the right triangle. That's absolutely the right triangle. Now, the issue with the right triangle was the following, that sine theta, fine, is hypothesis opposite over hypotenuse, absolutely correct. But this work only in the right triangle where the angle has to be less than 90 degrees. So everything here is fine as long as my angle is less than 90 degrees. So the question is, how can we generalize the definition? And that's really where the unit circle came into the picture. So let us remember the unit circle definition. Unit circle definition. Because in the right triangle, it's only right. It means the angle has to be less than 90. The unit circle definition, the most important definition for is the following. We start with the unit circle. Means the circle of radius 1. Okay, that's my unit circle. So that's the radius 1. Now we're going to define, we define the sine and cosine in the following way. So if you take, I'm going to do two pictures. If I take an angle here, and I'll call it theta or whatever you want. If the angle is between 0 and 90, it means I am in the first quadrant, then the sine is basically opposite over hypotenuse. It means if this point is x and y, it means from here to here I have a y, and this is a 1. So the sine, if I am in the first quadrant, because the angle is less than 90, the definition of sine is the same as the definition we just saw. It's y over the hypotenuse, which is 1. So we don't change the definition. But the question is, we're going to extend this definition. We're going to make it larger. So the question is, if the angle, we define it now that following. For any angle, so I'm going to draw. So this is if the angle less than 90. So, but if the angle is more than 90, how did we define the sine? Okay, so again, my unit circle here. And that's my unit circle. So the unit is important in here. And if I have any angle theta, no matter what it is. Okay. And this is my point P. And that's the definition, which is a very bizarre definition. That's why students have difficulties with it. There is a reason. And the sine was defined to be what? And the cosine was defined to be what? Okay, so if the angle is bigger than 90, so we're going to define the sine to be x coordinate of the point P, and the sine is the y coordinate of P. So some of you are still not having this clear. The cosine is the x coordinate. That's the definition. That's what it is. And the sine is this one, is the y coordinate. That's the definition for sine of cosine, what we call the unit circle definition. That's what it is. We have no other definition. Okay, so in the right triangle, we've covered it. In general, that's our definition. The tangent, everything else is the same as before. So the tangent is the same as before. It's the sine over the cosine. That's the tangent. The cotangent is the cosine over the sine. Everything else is the same. The secant, nothing changed. 1 over the cosine. And the cosecant is 1 over the sine. The main thing we did is we extended the definition of sine and cosine for any angle. So no matter what the angle is, even if the angle is like, I don't know, 1000 degrees, no problem. You start here, you go around the circle enough time till you hit 1000. You look at the point, you have the sine and cosine. So that's the unit circle definition, crucial definition. That's the one that you guys will use if you do anything to do with science. I mean, that's the definition you guys will use. The other one is restricted. This one always available. All right, with this in mind, I'm definitely, as I said, going through your exam number 1. So I'm gonna put a problem and you guys will have to give me. So exam number 1. So I'm telling you where I'm getting this from. Number 1. I'm going to do number 2 because it's immediately related to what I'm talking about. So I gave you a circle, unit circle. So assume this is a nice circle. I know it's nothing but the circle. So that's a unit circle. And I gave you an angle T right there. That's what I did. And I gave you a point. I gave you the, and this is a unit circle. And I gave you here the coordinate of this point, which was minus 0.76. And the other one is 0.64. So that was exam number 1, number 2. Okay, so that's your angle. I called it T. And these are the coordinates of this point. And then I asked you several questions. The goal is to practice the definition of sine and cosine. So my question was, what's the sine of T? And quickly, I want answers from you. Quickly, what's the sine of T? 0.64, because what's the sine? Never forget the sine is the y coordinate. That's my sine. And the cosine is the x coordinate. So the sine is 0.64, okay? Now, my question number 2 was, what's the sine of T plus pi? Okay, this is equal to what? Now, the only way we can answer those questions is by basically using the graph, using the circle, using the symmetry in the circle. So what's the sine of T plus pi? What do you think the answer should be? And then why it is what it is? Okay, all right, but what's the sine of it? That's the angle. No. No. What's the sine? Minus. Aisha tells me minus. Let's see why she is right. If this is T, where is T plus pi? Where is this angle? T plus pi. So that's a new angle. It's not the first one. That's a new angle, T plus pi. Where is T plus pi on my circle? In which quadrant is T plus pi back to you? If I add pi to T, which quadrant I'm going to end up? Quadrant number 4. So this is T. I'm going to add pi. It means I'm adding 180 degrees. It means this is right there. This will end up in quadrant number 4. Sorry. No, it's not quadrant 3. It's 4. Caitlin, do you understand why? This is the pi. Okay, so this is T. You're adding 180. So you're going all the way there. Yeah, then that's fine. No problem. So this is my angle now. This red one, this is the T plus pi. Okay, now what's the sine of it? All right, our definition tells me is the y coordinate. It's whatever this is. Now, what's the y coordinate? Now, the symmetry is going to solve our problem. Okay, the symmetry, it tells me, what's the y coordinate here? Back to you. This is minus 0.64. That's the y coordinate. So the sine is minus 0.64. Okay. All right. Cosine of T. So that was A, that was B. Okay. Cosine T. Equal. What's the cosine of T? That's T. What's the cosine? Back to you. Okay, Rebecca tells me minus. Exactly, because that's the angle. That's the definition. It's the x coordinate, which is the minus. So it's the minus 0.76. This is the cosine of T, because that's the definition. And I know what's hard about this idea is that the definition of cosine is the x and y coordinate. But it is what it is. That's the definition. I cannot really change it. Very good. So that's minus. So now let's suppose I ask you, what's the cosine of T plus pi? Back to you. Is this an easy or a hard question? Rebecca? What's cosine of t plus pi? It's the positive because t plus pi is in front of you. Its cosine is the positive 0.76. Okay. Now back to the questions on my exam. What's the tangent of t plus pi? What is the tangent? Back to you. You have several ways of doing the tangent. First, you locate the angle, which is t plus pi, and the tangent either sine over the cosine or the y over the x. So back to you, what's the tangent of t plus pi? Okay. What's the tangent? What's the easiest way to answer the tangent? It's the sine over the cosine. Exactly. What's the sine? It's minus 0.64. The cosine is minus 0.676. So that's the tangent is the sine over the cosine, or, so that's the angle, that's my point here, or it's the y, because the y is the sine over the x, because that's, and now the answer is, I don't care, it's just that. Then you plug in your calculator. This is not hard, but that's really what the idea is. Now the final one is, what's the tangent of minus t? Okay, so I want you to think a little bit this time. And before I ask you tangent of minus t, I'm going to ask you the following. Okay, so I'm going to drop this a little bit. What's the sine of minus t? What's the cosine of minus t? And then finally, what's the tangent of minus t? Okay. And I'm going to draw the picture again, because I need the picture again, right there. That's what you guys have. That's the problem. That's what you are given. Okay. And this is my t. That's the angle t. And this is the point, minus 0.76 and 0.64. That's the t. Now my question is, what is the sine of minus t? What is the cosine? What's the tangent? Back to you. This is the picture one more time in front of you. So what's the sine of minus t? First, minus t is in which quadrant? 1, 2, 3, or 4? If this is t, minus t is in which quadrant? Anybody? Is quadrant 3? Do we agree? Because what's minus t? It means you start from here and you go clockwise. This is your minus t. If this is t, this is your minus t. So this is minus t right there. Okay, so the same exact measurement, but you go in the opposite direction. So if t is in quadrant 1, the minus t is going to be in quadrant 3 in this picture. So what is the sine of minus t now? What is the sine of minus t? Now the picture tells me that those, we have symmetry right there. So what's the sine of minus t? Okay, I'm going to start asking student question and then proceed. Lucas, are you with me? Lucas, are you with me? Yes or no?
Yeah, but I'm still kind of having a tough time with this one.
Okay. Can you hear me?
Yeah.
Okay. Do you understand why this is minus t? Question number 1.
Wouldn't that be minus t just because on like the opposite of like the t over here, like it's the reflective.
Right, you go into the opposite direction, right?
Mm-hmm.
So if this is pi over 3 minus pi over 3, you go in the opposite direction. That's what it is. All right? Question number 2. What's the sign of minus t? If this is your angle, the definition tells me that the sign is, so let me call this point P. I'm going to call this point Q. Okay? The sign of minus t is the y-coordinate of Q. What's the y-coordinate of Q?
Shouldn't it be negative 0.64?
It's negative 0.64, yes. What's the cosine?
Should be the same, which is negative 0.76.
Yep. So it's much easier than you think. What's the tangent?
The tangent, I'm not sure.
It's the sine over the cosine. So you better be sure for the exam next time.
Okay.
It's the sine. Whatever the angle here you have, it's the sine over the cosine. All right? What's the sine over the cosine?
So the sine should be 0.64 over 0.76 or negative 0.76.
Yeah. So the tangent is going to be 0.64 over 0.76. And that's the tangent. Another way you can, so this point Q down here is minus 0.76 minus 0.64. So the sine is the y, the cosine is the x, the tangent is two ways, either sine over cosine or the y, because that's the sine, over the x, which is the cosine. Okay, I have a question, please, Jacob. What's your question? Jacob?
I'm here.
Okay,
Sorry.
what's your question?
I just tangent is positive in quadrant 1 and 3 and negative in 2 and 4.
Yes, tangent is positive in quadrant 1. Tangent is positive in quadrant 3.
Right. I didn't know you were doing the in the previous problem and this problem, I just in the previous problem you said it was like negative when it was supposed to be positive, and this one I thought it was doing the same thing, so I just wanted to clarify that.
Did I do a stupid mistake there? Here? Oh. Thank you. That's a negative one, right? That's what you're saying.
Right.
Yes, thank you. All right. So the tangent, go ahead, Jacob.
Sorry, I just wanted to reiterate that. I'm done.
Yeah. Sorry, that's my mistake. You guys should correct me. I mean, even we wrote this, I copied it wrong. Yeah. So tangent is positive in quadrant 1 because if you take an angle here, the y and the x are positive. The y over x is positive. It's positive in quadrant 3. It's negative in quadrant 2, negative in quadrant 3. Okay, so this first problem is actually a good, basically what I emphasize in this problem is the definition of sine and cosine. Okay. Problem number 3. Please ask question as I move on because this is what you guys will be tested on. I mean, this is part of it. Okay. Now I'm going to look at number 3 again in your review. All right, in your exam 1. I'm doing exam 1 with you. So I gave you a circle. Again, the unit circle. And the question is the following. Graph the points on the circle that correspond to the given angle. So I gave you an angle of 5 pi over 3. That's the angle. And my question is, graph the point that corresponds to this angle and find its coordinate. Okay, now 5 pi over 3. Let us remember where this point is. Now, pi over 3 is like 60 degrees because that's always very helpful. So pi over 3 is 60. So 5 pi over 3, you're talking about 300 degrees. So we're going to go here and 300 degrees. So 360 all around the circle. So this is going to be 5 pi over 3. Okay, so this is the x-axis. This is 5 pi over 3. Okay, so from here to here. That's the 5 pi over 3. It means what's left here is basically 60 degrees. So that's the point we're talking about. And then the question is find the x and y coordinate. So this point has x and y coordinate. We have to find them. All right. The x coordinate is, that's the unit circle, is the cosine of 5 pi over 3. And the y coordinate is the sine. So that's the definition of sine and cosine. Now the question is, what's the cosine and the sine of 5 pi over 3? And the question is, I asked you to find the exact coordinate. Now to find the exact coordinate, the idea is, it's nice usually to memorize special angle in the first quadrant, and then everything will be simple. So from here to here, if this is 5 pi over 3, which means like 300 degrees, right here, this little angle here is what's left. This is basically a 60-degree angle. So I'm going to take the one which is symmetric to it, right there. So this is 60. Right. Now, one piece we can remember is that 60 degrees, the cosine of 60 is a half, and that's what you have your unit circle, square root of 3 over 2. And this usually guides us all the time. So in my case, the cosine of 5 pi over 3 is going to be the 1/2. The sine is the minus of that, which is the minus square root of 3 over 2. Okay. So here is the opposite. Here in this problem, I gave you the angle and you have to find the x and y coordinate. In the previous problem, I gave you the x and y, and I asked you to find the sine and cosine. Here, I gave you the angle, and basically, I'm asking you to find the x and y coordinate. All right. So this is part A. Now, the other one is the following. I do part B. My angle is minus pi over 6. So again, we draw the unit circle. That's my unit circle. I draw it again. That's 1. Minus pi over 6 means we start and we go clockwise. Pi over 6. So that's minus pi over 6. It means minus 30 degrees. We end up a point right there. And the question is, I need to find the x and I need to find the y. All right. Again, the x is the cosine of minus pi over 6. And the y is the sine of minus pi over 6. Okay. So now the question is, what's the cosine and what's the sine? Now, as I said, that those are very particular angles. So I'm going to go to pi over 6. And this one, we should remember those, pi over 6. The cosine is the square root of 3, and this is a half. So now the question is, what is the cosine? So if I know that, I should know this. The x is square root of 3 over 2. The y is minus that. So if this is a half, it's going to be minus a half. Minus a half. Okay, so if I take any point on the unit circle, if I know the angle, the x and y are the cosine and the sine. Please ask questions as I move on. Okay. Now I look at number 4. Again, I am in exam number 1 because if I cover the exams, you guys should be able to do the review very easily. Number 4 is based on the following idea. If I take a circle, but the radius of a circle, not necessarily 1. So the radius is r. So the radius is r here, okay? And I take a point on the circle, and this is an angle, T. So I get a point here on the circle. What are the coordinates of this point? So that's not the unit circle. The circle of radius r, the coordinates are going to become r cosine theta, r sine theta. So in other words, if P on the circle, radius r, then the x coordinate is r times the cosine, because everything is going to be stretched by a factor of r, and y will be the r, the sine. Okay, and everything is based on the definition of sine and cosine. That's what everything is based on. So for example, in number 4, so that's really here the idea, number 4. The question is, find the coordinates of the point P on the circle of radius 8 determined by the angle 130 degrees. So I read it. Find the coordinate of the point P, which is on the circle with radius 8 and form an angle of 130 degrees with the positive x-axis. Okay, so I have a point on the circle of radius 8 and the point form. So that's really what the picture here is. Actually, I'll take another page here. So here I have a circle. That's my point. This time the radius is 8. So from here to here, it's not 1 anymore. And the angle 130. So that's 90 degrees. So we're going to add a little bit more right there. So this my angle here is 130. And this one, I'm not asking about the exact coordinate. So this is 130 degrees. And that's the point. So my point is the second quadrant. And the question is, what are the x and y coordinates? It means I want this. So we know that the x has to be negative. And we know that the y will have to be positive. Okay, so let us see what the formula tells me. The x coordinate is going to be the radius times the cosine of 130. Now 130 is not a special angle. So this we use our calculator to evaluate. And the y is going to be the 8 times the sine of 130. And we should be careful that we have to have negative here because my point is in the second quadrant. And we have to have a positive here because my point is in the second quadrant. And now for this one, it's just picking up calculator. So usually my calculator is in radian mode because as I told you in calculus, you will use the radian all the time. Actually, it's in degrees, so probably I was doing something with this class. So it's 8 and the cosine is 130. So it's minus 5.142, 0.142, and my sine is 8 sine 130, and I get 6.128. Okay. All right, so this is the sine and cosine on the unit circle. Now, number 9, again, we focus on the same idea. So okay, I have 5 more minutes. So number 9. Okay, the idea is always the same. We're really, all those problems is to understand more and more the unit circle definition of sine and cosine. And next time I'll emphasize the graphs, which are crucial. So this problem is the following. I gave you an angle, which is 70 degrees. Okay. And here's my unit circle. So 70 degrees will put me somewhere here. That's my angle. So from here to here, it's 70. Okay. Now, the question is, can you give me another angle who have the same cosine as 70 degrees? Can you think of another angle that have the same cosine as 70 degrees? So my question to you is that between 0 and 360, how many angles do they have the same cosine between 0 and 360? Back to you. How many angles between 0 and 360 have the same cosine as 70? Okay. So how many angles? How many angles between 0 and 360 have the same cosine? This is 70. Its cosine is the x-coordinate. Okay. Can we find another? Yeah. Can we find another angle that have the same x-coordinate between 0 and 360? The question is yes. If I take that angle from here to here, those both angles have the same cosine. So if I know the cosine of 70, immediately I know the cosine of that angle. Okay, so give me another angle of cosine is 70. We go back to the picture. We say, okay, this is 70. Its cosine is the x-coordinate. Can I find another angle who has the same x-coordinate? So we just go the same x-coordinate I want. So we go just to the fourth quadrant. So this is going to be equal to what? What's this angle here? We look at the picture. This angle is 180 minus the 70. Sorry, my apology. This angle is 360, the whole thing. You're taking away 70 from it, which is going to give me the 290. So this is the same as the cosine of 290. Again, this relies totally on our definition. The cosine is the x-coordinate. So can you give me another angle that give me the same x-coordinate? Yeah, we go the one opposite to that. Okay. All right, problem number 2 along the same line. Cosine of 215. Give me another angle between 0 and 360 that have the same cosine as the cosine of 215 degrees. Okay. All right, we still have 2 minutes and I want you all to be able to do that. Draw the unit circle. Draw 215 on the unit circle. And then ask yourself which other angle will have the same cosine. Question number 1, 215 is in which quadrant? 215 is in which quadrant? Quadrant 3, do we agree? 215 is in quadrant 3. Yeah, that's 180, that's 270, so 215 is somewhere in here. This is 215. What is the cosine of it? It's the x-coordinate. Okay, give me another angle. First, we're going to graph the angle and then we find it. Which other angle will have the same cosine? It's the other angle which will have the same x-coordinate. It's this one. Okay. And now the question is, how much is this angle from here to here? Okay, how much is this angle? Just look at the picture. How much is the red angle? Anybody beside Jacob? I think Jacob is right. I don't know. I usually don't do the math myself. Anybody beside Jacob can think what's this red angle? Okay, Jacob, how did you get it?
I subtracted 180 from 215.
180
Correct.
doesn't give you 145.
$180 from 215 gives you 35, correct?
Okay, so which angle this give you? This one here?
Correct.
Okay, so he found this angle. So there are a lot of ways to doing this. So it's just, so he found 335 here. Because
Right.
this one right here is the 215 minus the 180. Let's give him 35. Okay, so the red one is what?
And then you do 180 minus 35.
Minus 35, which is 145. Can anybody think of another way to do it? That's absolutely correct. Who can think of another way? Just look at the picture. Let me ask you the following question. This dotted line is how much? The dotted line. This is 215. Another way? Another way you do it is you take 360, everything, and you take away what am I thinking? Okay. Okay, you guys make my mind go blank right now. So this is absolutely correct, but there is another way to do it. Is you take 350, and if you take from it the 215, so you take 350, you take the 215 away from it, you end up with this angle here, which is the 145. Okay, so I repeat because I think I confused you. So another way to do it is like that. That's 215. And I'm interested in that. So this is the 215. Okay. So another way to do it is you think of this angle from here to here. So this angle here is 360 minus 215, which is the same thing as that one, which is going to give you the 145. End of the problem. All right, so I stop here. Next time I will finish the review with you. I mean, big part of the review. I will do one more problem along those lines, and then I will finish exam 1 and exam 2. And as I said, we will have a very short quiz, and the quiz will basically cover ellipse and circle. So go over the problem with it in class and make sure you can redo them, okay? Wait, so did you say you would? Yeah, yes, I did say I will drop the lowest 2 quizzes. I was very clear because this last quiz was not on the syllabus. Since I am giving it to you and it's not on the syllabus, I will drop the lowest 2. Is that very clear? Okay, all right, any questions? Okay, so please bring with you the exam 1 and exam 2. That will make it very much easier for us to talk about